Hello everybody and welcome to this session today on battery energy storage and the role it will play in integrating renewables into our future energy system. My name is Dr. Matthew Rowe and I have the pleasure of chairing this session today. I'm an electrical engineer by background. I head up a department of consultants at DNVGL who all work in technical energy storage advisory services. And I have the pleasure today of being joined by Brian Warshay from the US, our US team at DNVGL, and with Medina McAnuva from the market director at Fluence. So I'm really excited about our session today. I've got two great speakers with me. We've all shared thoughts already in preparation for this session, so I know there's lots of interesting things that we want to try and get said. But just to set the scene, I just wanted to spend a few minutes just talking a bit about why this is an important topic. As countries and corporate organizations of all sizes around the world commit to transitioning to net zero, we're beginning to see a significant uptake in the amount of renewable energy being deployed. Such a significant amount of renewable energy, combined with the electrification of heating and transport, brings with it challenges to our energy systems, as they are forced to be used and operated in ways that they were not originally designed. So, for example, we see less inertia on the system, which was typically provided by conventional generation, as well as less flexibility on the generation side, making the demand and generation balance a lot more difficult. And not only can storage support in helping to solve these problems, but it can provide a variety of other applications as well. So this session will explore the value that energy storage can provide in supporting the integration of renewables, looking at different applications and roles that storage can play, both when directly co-located with renewables and also as standalone systems as well. We'll look at different business cases and the revenue streams and draw on different examples around the world. And the panel will also explore the value in integrating storage with wind projects and why we see significantly more solar and storage projects around the world. The panel will also explore the impact of how we operate energy storage on greenhouse gas emissions, which is a topic that Brian is very fond of, and we'll explore that. And finally, the panelists I have here have a wealth of experience and lessons learned from deploying projects all around the world. And it's also down to you, the audience, to be asking questions to our panelists, as we really want to hear from you. We want this to be driven by the questions you ask. After this session, we're going to be joined by two other DNVGL experts, and we're going to explore some of the technical attributes of storage. So diving into the current status of things like warranties, battery degradation, what we would do in a technical due diligence, look at the topic of battery fires, some of the incidents around the world. So technical questions we'll try and save for the later sessions. We'll try and go through some of the market stuff first. So that's enough from me. I'm going to pass over to our speakers. So thank you both so much for joining us today. Medina, I was wondering if you could start just by introducing yourself and sharing your thoughts on the role that storage will play as the penetration of renewable energy around the world grows.
Thank you, Matthew. Good afternoon, good morning. Brian, Matthew, great to join this session today. I would like to start with introducing Fluence. Fluence is a global battery storage technology and services provider. I'm a market manager for the Middle East and Africa at Fluence. It's a joint venture between Siemens and the AES Corporation. I was part of the AES energy storage team that helped to launch Fluence in 2018. Currently, Fluence is the leading company with over 2.4 gigawatts of battery storage projects across the globe in more than 22 countries, with more than 100 projects. We are excited to see the path and the growth of storage in the world. In the past, I have been heavily engaged also in the European projects, but currently my focus is more on Middle East and Africa and some key markets there. I have a Master's of Engineering in Technical Physics and a Master's of Engineering in Energy and Environmental Management in developing countries from Flensburg University in Germany. Responding to your question on the role of energy storage, to mitigate the penetration of renewable energies. I think it can be viewed in two ways, as you just said, that we will touch different aspects of it, but there are two main directions that I see. It's a direct and indirect impact that and battery storage brings to the grid. In terms of direct is when we have renewable energy co-located projects where there are obvious applications like firm output, grid stabilization, or a ramp rate control for solar projects. And indirect, when we have standalone storage systems or co-located with other generation assets providing other services such as black start, frequency, voltage regulation, all dedicated to increase the renewable energy in the grid, but working, let's say, more indirect way by managing the grid stabilization. So that's the way I see it, and we will be happy to share more examples through the discussion.
That's great. Thank you very much, Medina. And it must have been really exciting to be part of Fluence as you've gone through that journey since starting with them in 2018. I mean, to see the amount of growth that Fluence have achieved is brilliant. So yeah, it must have been a very exciting time for you. Brian, yeah, it'd be great to hear the same for you. So if you could introduce yourself, talk a bit about your role, and give us a feel for what you think the role storage will play as the penetration of renewables increases.
Awesome. Great to be here. I'm coming to you from snowy upstate New York these days, if it wasn't abundantly clear from my parents' house here. But I have been with DNVGL for almost a year and a half now on the North American Energy Storage Engineering team. Prior to that, I worked at Solar City and Tesla on the energy storage products. And prior to that, I worked in market research at Bloomberg New Energy Finance, researching energy storage and other grid edge technologies. So I've come at the topic over the past 10 years from many different angles, from third-party research, from working on products, and now more focused on consulting. And most of what we do in the U.S. on this team is to support due diligence around energy storage project transactions and the bankability studies around energy storage products. So we get a really close look at a lot of the technical specifications and contract documents that go into these projects that get put in the ground, and we help support the industry in moving those forward and aligning on industry standards that are much more common in the solar and wind side of our business and starting to evolve very, very rapidly, actually, on the energy storage side of the business. So for us, for me, it's very exciting because things are changing and there's a lot of new products, a lot of new business models, and it's really been interesting to see things evolve on a daily, monthly, weekly basis. As far as what we're seeing in the market here, and my bias is certainly a little bit towards North America. I agree with Medina. There's kind of two different approaches, but I think about it more from using energy storage to integrate renewables from an energy perspective, helping intermittent renewable energy resources deliver energy in a more firm, consistent basis, a more reliable basis. And a lot of that is driven by pricing that often results from an overabundance of, for example, solar in the middle of the day and using storage to shift that into the evening, which creates price differentials, which creates an opportunity for energy storage to play. The other avenue we see a lot of is using storage as a infrastructure resource to avoid traditional upgrades. And this could mean storage is sited in different parts of the grid, not just at the edge on the generation side, but more integrated into the transmission and distribution system, all the way down to maybe the other edge at the consumer side. And we're seeing a lot of innovation around how storage can be utilized in these kind of disparate ways to provide to resemble physical infrastructure services that utilities would typically own and operate. And it's interesting from a technical perspective and also from a regulatory and business model perspective and how these assets get integrated into the system. But by and large, the outlook for the industry globally and certainly in North America is pretty robust growth expected for the next few years, even with the current in the current state of the market, the current state of regulations, with no new incentives or programs. We expect significant continued growth, and looking forward to talking about that more.
Thanks, Brian. Yeah, the US market's been amazing recently. I read earlier that in Q3, over 250 megawatts worth of assets were deployed just in the US alone. So it's amazing to see the growth that we're seeing in batteries over there. Medina, I've got a question. Like you're focusing on Africa and the Middle East, but I was wondering if you could give us a few examples of where you've seen policy and markets that are supporting the integration, using storage to integrate renewables. Are there any example markets that we've seen pop up, or any policy that's popped up that's really where we've seen storage get installed that's going to help more renewables get onto the system?
Sure. I will give a couple of examples. One of them, let me start with one of them, and I think it will give an interesting angle to how to see how markets are approaching the penetration of renewable energies and how different can it be. So when we think about Europe, I want to give an example of Ireland. The Republic of Ireland, that has a program in place, maybe some of the participants know, which is called Delivering a Secure, Sustainable Electricity System, which is a path of Ireland to achieve 70% of renewable energy by 2030, and their target for 2020. In 2017, they already achieved 30%. Just important to mention here, because every country has a unique journey when they target different levels of renewable energy. And why is it unique? It's the specifics of the country and the renewable energy types and the historical existing grid and all these aspects that come into play. So talking about Ireland, under this program, there is different packages of services. Actually, there are 5 services for grid stability products that are providing the services for the grid to actually manage the frequency. And faster your response is, more earnings you have. There is a 6-year contract that you get. So this way, there are storage projects that already installed or will be installed under this project. One of them we have commissioned last year, 11 megawatt storage system, 30-minute, collocated with a wind farm, but it's not actually directly connected because it's not the same business case. Storage system is providing the services to the grid. And this is one way of doing it, and the program is actual, and there will be more projects like this. And on the other hand, I would like to give as an example Israel, the country that has last year awarded more than 2 gigawatt hours of storage projects co-located with solar. These are long-term PPA contracts where the storage system is co-located with the PV plant with not less than duration of 4 hours. And this is a totally different approach. Both countries have a limited access to grid networks. So they're kind of an isolated systems, but they are taking a different pathways in terms of addressing these plans for having storage in having renewables in the grid. Israel has a target to achieve 30% by 2030. So they are just, let's say, at the beginning of the journey comparing to Ireland, but at the same time they're approaching it so in a different way from regulation, from the how the market players can build up their projects. That's exciting to see. So these are 2 examples, I would say. And if we talk about Africa as, again, a continent, every country is different. There are different needs in every country. There are some activities in South Africa which are also like IPP type projects. So I think we would see again a very different paths there in terms of introducing more renewables and having storage systems operational.
Yeah, thanks. That's really interesting to see the 2 different examples where you have these 4-hour longer duration, like 4-hour systems, and then 30-minute systems in Ireland, but actually both of them are there to help support the integration of more renewables onto the system. And Brian, what do we see in the US? Are there any markets that have been set up there to help the penetration of renewables with storage?
Sure. It should come as no surprise to most of the audience. California is one of the biggest markets here in the U.S. It's physically one of the biggest anyway, and certainly has a lot of renewable energy penetration that's already kind of been put in place. And as a result of that, and the fact that there is a merchant market operator in the state, the transparency associated with the prices that result from the high penetration of solar, and there's lots of wind as well, create an opportunity for storage. The way storage, generally makes money, which is different from fossil fuel plants, at least in the merchant market aspect, is by buying low and selling high, right? It's arbitrage it's the volatility in the pricing rather than the absolute pricing. And the abundance of solar, for example, does create that opportunity where once solar kind of comes off roughly around the same time of day, every day, and it varies by season, but there's an opportunity for storage to leverage some of that. But where we see a lot of the projects today capturing value in California is through a product called resource adequacy. This is most similar to what is often called a capacity product in other markets, where different load-serving entities are required to purchase essentially firm capacity, which has its definition in California. A 4-hour battery qualifies as eligible for that, so 4 hours of discharge capability at a given megawatt rating. And that allows these load-serving entities, essentially utilities, to purchase what they would consider, at least for their constituents in most cases, clean resource adequacy. So this would be a battery that is charged with solar. There's a couple reasons for that. The federal investment tax credit in the U.S. allows energy storage charged with solar to actually get a 30%, now 26% credit or rebate on the upfront cost. So those two kind of incentive or programmatic situations in California does create a significant opportunity. And what's nice about resource adequacy is it creates a firm revenue stream for the project, and also allows the battery to be operated in somewhat of a nuanced way by the operator in that merchant market in California. So there's also an upside or opportunity or expectation about how the battery can make money in the purely merchant market in uncontracted revenue streams. And so we're seeing a lot of projects and actually some mega projects that kind of fit the bill there, both AC and DC coupled solar and storage, trying to access these revenue streams through these different contract mechanisms. Hawaii would be the next opportunity where it's a small physical market, but with a huge penetration of renewable energy, a lot driven by the fact that electricity prices are very high there because it's an island. Many islands, they used to import a lot of oil. It's very expensive, very polluting, and there's a strong push for renewable energy there. So a lot of large contracts we're seeing happen there with some pretty unique mechanisms. But overall, it's a small physical market, so there is limited opportunity there. But outside of those, there's the other two areas I'll touch on quickly that probably don't get spoken about as much, but do have a lot of opportunities for storage. In Texas, for example, there's a lot of volatility in the energy market there, which does not have a capacity mechanism. And there's a huge amount of wind in Texas, which creates different pricing and volatility associated with the energy market there that storage developers and a lot of standalone storage developers are taking advantage of. Speaking to what Medina said, kind of indirectly integrating the renewables into that system. And even in places like New York and New York City, it's maybe not directly integrating renewable energy, but it's getting in these load-constrained pockets of New York City, it's getting fossil fuels out and putting storage in via essentially charging storage from the grid, maybe from cleaner energy that's coming from different parts of the state, but not having that physical on-site pollution in New York City and letting the storage kind of fit into that physical area in the city to avoid turning on old gas and oil plants. So we're seeing a lot of different opportunities throughout the country. Each state kind of acts as its own unique market, and much like Europe and other places. So a lot of activity, a lot of different approaches.
Yeah, I mean, I guess just listening to you both, each country is on such a different journey, and that could make deploying storage really difficult to understand if you're going to deploy it across multiple countries. And I guess something that both of you see in your roles. I actually want to pick up on a point that each of you said, but ask the other person about it. So Brian mentioned DC coupled and AC coupled systems. So Medina, I'd just like to hear your view on this. I mean, do Fluence have DC coupled and AC coupled systems? Like, what do you see within these different types of connections?
Yes, well, thank you for this question. I actually really like solar application. Well, I like wind application as well, but solar is some kind of more, let's say, distributed, and it's a technology which is a little bit easier than wind to be accepted. Therefore, I see more solar plus storage projects currently, and lesser wind plus storage projects. So indeed, as being innovative company, having more than 12 years of experience, we started looking at DC connected systems a few years ago. We had at that time, because we were closely looking at solar plus storage application, and this is the only application when we actually talk about DC connected systems. So the AC connected systems are used for most of the applications. Battery storage, lithium-ion technology is used that we are focusing on at the moment. And DC connected systems are, let's say, a lesser portion for the specific application, which is solar collocation. We have 6th generation platforms launched last year in June. These have and for grid connected storage, there are 2 platforms. One is DC connected SunStack, and the other one is Grid Stack for AC connected grid projects. So when we talk about those projects, so if we talk about solar application, there are different ways of being paid for your storage, so having your business case work. So the difference between DC and AC, that you have a DC-DC connection that limits you in terms of providing some services to the grid. Therefore, the question would be what the storage will be used for. Is it only for simple time shifting plus stabilizing the output of the solar plant, or would you like also to do some additional revenue streams, provide some services to the grid, all the things that can be different types of applications that can be stacked together with the solar application? So I would say that's the question number 1. And the second one is, are there any benefits of having storage co-located? Because as we said, there is an indirect way as well. If you have an AC connected storage system, you can basically you can connect it to have it on the same field, or technically you can have it in another field, maybe a few meters away, or even in another country. So the question is, do you actually need them to be collocated? If they are collocated, of course, there are benefits that are some soft improvements that, first of all, from procurement perspective, then from connection perspective, then from people and other resources that you have there. But from the AC to DC, there is some cost benefits as well, but it's really project specific. So there is that you need to have a look at the project. So that's the question 1. And the second one is that the DC connected system is a little bit more complex in terms of designing, because you need to have a view over your solar part to be able to design your storage properly. And as well, they share the same inverter, the DC-AC inverter. Therefore, you need to put some more efforts to design both systems together. And so that's basically the difference. And from the duration perspective, I think what I see is DC is usually used for longer duration, because it's solar application. It's usually longer duration systems. However, because if it's shorter, that usually your business case is for the stability or some other applications like ramp rate control. These are usually shorter duration systems if you don't need to shift the power. So that's especially if we talk about the storage systems to be connected in the grids, which are very weak, and you cannot connect your solar without it. As an example, let me give I think we have recently launched a project in Chile, which is a 112 megawatt 5-hour system. It will be co-located with a 180 megawatt solar plant. And because the application and because it's remote location. There are other aspects to that. It is actually a DC connected system, but there are some project specifics for the specific technology choice in this case. Yeah.
Well, that sounds like a great project in Chile, a big system being installed there. Yeah, and I guess not only so the countries are different, and then we know the projects need to be specific as well. So Medina, I guess a lot of the work you do, I guess a question from the audience listening is, who does that work, right? Is that something Fluence do to look at the AC, whether or not it should be an AC/DC system, or is that something your customers do and then come to you? How does that work?
So we have a role of energy storage technology provider. So we engage and work closely with market players, with customers, with utilities and other players to actually see how technology will support the specific project. From the perspective of understanding that, I think it's a combination, but typically if it's a very complex project, we usually recommend for the customers to have a look at it, maybe together with consultants like you. Because it's helpful to have that, let's say, in-depth understanding of your business case around financial models. And sometimes it's even like benefits. I think Brian can talk about it, like tax benefits in US and more regulation-specific topics, like if you have AC, what connection you have, is it DC? Because, for example, in some countries, the land is the issue, the connection is the issue. So I would say from our perspective, we support as much as we can, but typically we start engaging when the project is more defined from technology perspective, or at least the parameters around which we need to design the system are defined.
Yeah, okay, thanks.
Hope that responds to your question, Matthew.
Yeah, no, definitely, that makes sense. Actually, before I come to Brian to pick up one of the points Medina made, I just wanted to say to everyone, I mean, it's great to see the chat box being filled up with questions, or the question box. You can upvote on questions that you'd like our panelists to answer, and please feel free to keep adding questions to there, and we'll come to those questions in a minute. Just a reminder, in our Meet the Expert session, we're going to be joined by Alistair and Mariana, who will talk more about the technical side of the assets as well. So I can see some questions coming on there, which we'll also save for some of our experts later. And Brian's also joining us for the Meet the Expert session, so we can pick up some of these other market questions as well that are coming through that we might not get to in the next 15-20 minutes or so. So Brian, earlier Medina made a comment about wind systems and storage systems, or solar and storage systems, not being sat next to each other but not connected. I mean, from my perspective, it seems like, if they're next to each other, they should be moving energy in and out and storing it. But I've also heard that's not the case always. Could you explore that and explain that a bit more?
Absolutely. On the solar side, certainly the DC versus AC aspect that Medina was just talking about kind of speaks more to that point. We would really think of a DC connected solar and storage system really as fully integrated. And it doesn't have to be 100% charged with solar, but it certainly would be in the US for at least the period that the investment tax credit I mentioned is applicable. And for all the things that Medina mentioned, that those projects I would think are typically more like what we think of as integrated. And then a lot of the AC connected storage, solar and storage in the US is, what I would really consider integrated, also primarily because of the investment tax credit. It requires solar charging, so there's an accounting that needs to happen to demonstrate that that system was effectively charged by the solar, even if the solar DC gets converted into AC and then back from AC into DC to charge a battery and then back out again. Slightly higher losses, but the investment tax credit is well worth it for usually the 5 or 6 years where that benefit applies. And then after that point, the projects may look more co-located and not as fully integrated, depending on the offtake structure and the operation of the battery that's chosen by the owner. The wind side is a bit different. In the US, the kind of parallel to the investment tax credit is the production tax credit, and wind projects typically utilize this mechanism, which offers an incentive for every kilowatt hour produced by the wind farm. So any production tax credit eligible kilowatt hour from a wind turbine that goes through a battery ultimately would end up with slightly less energy, which would reduce, both the amount of energy you sell and, of course, the PTC benefit. And that's why we've seen a lot less integrated storage with wind projects. However, for a lot of the reasons Medina mentioned, we certainly are starting to see more storage co-located with wind plants because the land is already owned, the interconnection is already existing. There might be a lot of wind plants might be close to a lot of other wind plants that are having impacts either on the transmission infrastructure and resulting in congestion or pricing that allows the storage itself to stand alone as an economic investment, even though for being co-located, but not necessarily directly charged from the wind. So the other side we see is some wind projects are getting, at the point in their life where they're getting repowered, and developers are thinking about how to integrate storage with the repowering. For example, if you're repowering a project with a specific interconnection limit and the new repowering technology is much higher power output, that interconnection limit may come into play, but storage could actually help firm that wind and allow you to maintain that interconnection limit by using the storage to charge. Matthew, we spoke about this, that the seemingly obvious application of storage with wind is to deal with curtailment when the wind plant has to actually turn turbines down for economic or physical constrained reasons. This certainly makes sense when it happens, but the frequency and the magnitude at which that typically happens is usually not cost effective for storage. For example, if an entire wind plant needs to be curtailed or go into a battery, the battery is usually not going to be big enough to consume all that energy. Certainly it would capture whatever it could at that time. Also the frequency in at least a lot of locations that we see projects in, the frequency of curtailment is not at the point where that application alone makes the project super cost effective. But if things, in certain areas where there's more congestion or more wind, that particular application might come into play a little bit more.
Yeah, because you're right. I mean, it does sound like a natural, obvious connection between renewables and storage, that when your wind gets curtailed, you store it up. But if the financials don't make sense, then we're not going to see it happen at the moment. And yeah, so I think that's a really good point. Thanks for exploring that one, Brian. Medina, I actually have one more question for you, and then we'll take a few questions from the audience. I wanted to talk a bit about warranties, actually, because warranties play a really important part in the business case. They play a big part in why and how you deploy these assets. I think it'd be great to hear what Fluence are up to with warranties. What do these warranties for storage assets look like?
Yeah, it's a very common question we always get from the old times as well, when lithium ion was not that strong as a technology, and people were asking about how battery degrades and how long the storage system lives. Now we are there when the storage system can be built up to 20 plus years, and we have guarantees in place to have that backed up with manufacturers. So that's I think the way I see it in the last couple of years, the technology evolved so much, and with that we also have shift to a more flexible use of storage systems that comes with the very flexible warranties. So Fluence has a flexible warranty in place that allows customers to, if they're not very certain that what they're going to do in year 5 or in year 10 with their storage systems, that they have certainty that their system will still be guaranteed with a flexible warranty. For I think the flexibility that storage brings certainly now is really is a certain flexibility, that you can be certain in this technology, and you have the warranties from our side. I would say from our side we have different packages, but the way for different markets. However, as I said, 20 plus years projects, most of our projects are all of the projects are commercial, therefore they're all going through the traditional financing with different ways, of course, sometimes from development banks, sometimes from private market and other sources. So this way, we as a global company with projects, we have to go through different due diligence processes as well. So we have a strong package of warranties. This is another point that we come to understanding how mature this technology is. The lithium-ion technology currently is a leading technology for battery storage projects. Let's narrow it. And the way it's becoming more and more accepted as a technology, and warranties and guarantees are better understood as well. So how it works, it's a little bit complex because the storage has a piece of the part which is called degradation, which is it makes a little bit more complex to understand in how it works. What it is also takes into account the system design. So that's let's say a little bit different. I think that if you would think about solar, when you have a little bit certainty about your generation constantly, and in storage you have all this flexibility that you need to build up in your project with guarantees and warranties.
That's great. Thanks, Dina. So I just want to spend the last 10 minutes of this bit before we go to meet the expert session, just exploring some of the questions that the audience have asked. And our most up-liked question is a question I'd like to ask Brian, which is, we've talked a lot about batteries today and the role that batteries will play in ancillary services or power smoothing or whatever, all the different applications. But do you think that there are other technologies that could provide these as well? Like the examples here that are given are things like gravity-based, the energy vault, gravity-based system, or hydro storage. Like, why do we see more batteries at the moment, Brian?
Simply because lithium-ion has been used for longer and demonstrated its capabilities, even if there's still some uncertainty associated with the products. Lithium-ion is used in our cell phones, in our laptops, in our electric vehicles, and just the sheer number of hours of experience that's associated with those products has been well demonstrated and is pretty well understood. Compared to some of these newer technologies. The other obvious one is it's cheap now. It's very cost effective for a lot of these projects. The projects that we've been talking about, Medina and I and others, are cost effective. They're not pilots. We're not, we see pilots doing some pretty wonky, interesting stuff. But by and large, the projects we're seeing come online over the last 18 months, and certainly the projects we're working on now that'll be built in the next 2 or 3 years, they're cost effective in their application. And the products, the storage products, the batteries are available and able to be mass produced all over the world in a pretty consistent and well understood way. And there's been constant improvements to lithium ion batteries. They've been small, more incremental, but those tend to add up. So all of that experience in the field does allow those products to be the most common in the projects that we see. Is there opportunity for other technologies? Absolutely. There's so many interesting technologies. I've been looking at this industry fairly closely for about a decade, and I've seen more of those new technology companies fail than succeed. So I have a healthy bit of skepticism when I do look at these technologies, even if they sound really good on paper. The economics seem to make sense. There's not always, it may not scale. It may not work in the locations. It may not be useful it may sound like a really good technology, but the application for which it is designed, for example, let's say a 20-hour storage technology, might not be a cost-effective application at this time. But certainly when you do modeling of the grid and distribution system and you look at very high penetrations of renewables, 40, 50, 60, 70%, kind of like what Medina was talking about, there are opportunities for that we expect to see for these longer duration technologies. And I would say most of the novel technologies that we're seeing developed are in this longer duration, 4+ beyond hours of discharge duration. And that's what we're seeing from a couple of different developers. So it's always exciting to see the new technologies come on. Some are niche, some technologies that are technically store heat energy by using industrial waste process heat. That makes perfect sense for those types of applications. And some are these large scale gravity-based projects that could come online and do some pretty interesting things in certain places. DMV, when we look at these technologies, we always tend to take a conservative approach and try to look at all the available data and try to understand what the technology can do and then what the market can do before we can, consider a technology bankable or give it, be confident that it'll operate for the length of time that they say it will operate for. So it's a long way of saying there's a lot of cool stuff that's coming online. We definitely think some technologies will be successful, but we've seen many more technologies not do well compared to lithium ion as do well. And we've seen some lithium ion companies fall by the wayside as well. But
yeah, so from Fluent's perspective, let's say in the last 2 years, we've of course tried different types of technologies as well. Our general philosophy is to stay technology agnostic and also observe all the technologies out there. The other advantages, just a couple of them that come to my mind while Brian was talking about the modularity, that it's really modular. Second is the time. At the moment, the time is becoming more crucial topic because, for example, in Africa, it's very important to have the power as soon as possible. And sometimes we see projects should be like delivered in 1 year. In the past, in general, the power sector would plan for multiple years projects, and with solar industry and the renewable energy industry moved the time of the projects to much shorter timeline, which also brings always to the point like when we can have this storage system online. Therefore, let's say the typical time now is like 1 year for 2050 plus projects, and that's amazing, I think, in terms of how industry is looking at different types of technology. And there is always different types of technologies that we also ask customers sometimes, like, for example, if there is like intraday shifting, seasonal shifting, then we would certainly advise customers to have a look at different other technologies. That is because there are some projects when it's obvious that there are some other technologies more beneficial for the project.
Yeah, thanks. Yeah, thank you both for sharing your thoughts. There's a question actually here which has been upvoted the most, so we're going to go with what the audience wants. This is something that's been asked for all the time I've worked in the industry, and that's the difference between or the value and which is the better solution in terms of distributed storage and big single installed systems. So whether we have things like big production plants or lots of distributed medium-sized storage. And we've seen some massive projects announced in places like China and the US, but what is the right way of doing this? I mean, is there a right and a wrong way? Where do we expect it to go? Would one of you like to have a go at sharing thoughts around that?
I can start, and I'm sure Medina has some opinions as well. It always the easy answer, of course, from our side is right. There's going to be a mix, and I think it's impossible to say anything otherwise. To say it's going to work one way or the other. We have the grid historically has been built upon large centralized power plants, but the fuels that provide energy for those power plants has varied in every grid around the entire world, right? There's coal, gas, oil, nuclear, now solar, wind, and geothermal, and others. So there's no one right power generation technology. There's no one right type of storage or one right location for storage. I think most of the projects that we see today are these larger centralized projects that are paired with a renewable project or standalone on their own. But the distributed projects are super interesting and offer a lot more nuance to the technology and how it can be applied than some of those centralized projects. In the fact that batteries can be dropped in the middle of a city at someone's home, and they can serve many grid services as well as hyperlocal services to that customer on their site in terms of managing their retail energy bill. And most importantly, at least when it comes to residential storage, is providing reliability for that customer's home when the grid goes down. And I think that's something that no one knows has a precise number on what a customer was willing to pay for storage, but we know people are willing to pay for that reliability aspect utilizing storage. It's cleaner than a generator. It's not noisy. It turns on instantaneously. It could be powered by your solar panels on your roof almost indefinitely. And I think the fact that those grid outages happen, at least in most most advanced or modern grids, very, very rarely, right? So you have an asset that's sitting there underutilized most of the time. And I think that is where there's some super interesting platform opportunities that utilities and technology developers are working on. You hear the acronym virtual power plants that are utilizing and tapping into these distributed resources to provide energy to the grid outside of the physical location where they are, avoiding infrastructure investment and a number of other plays. And I think that's where I would expect to see a lot more innovation and creative uses of the technology. And it's very exciting for those reasons, but there certainly will remain some large centralized storage projects that look more like a conventional power plant at a high level, though there's a lot of nuance there too.
Yeah, okay, thanks, Brian. Did you want to add anything to that, Medina?
I would just think as well in the two ways that when we look in the grids that already quite advanced and they are increasing the number of renewable energy projects, then we would talk about reshaping the existing grid, having, for example, virtual transmission, as just Brian said, like different load centers closer to the source of energy. But when we talk about the grids where is lower the quite not developed grids where the power needs are, then they can be initially shaped as distributed grids, being, let's say, especially in the areas where there is a issue with distances, and some countries have really huge problems around that with, let's say, kilometers of lines that cannot be built. So then that's another different types of planning, I would say, those to meet those challenges, to actually maintain them and have storage systems in these systems.
Yeah. Well, that's actually, we're just overdue on time, and Brian's going to stay for the next session. So Medina, I would just like to thank you so much for joining us today. I always enjoy sharing conversations with you and hearing what's going on, and Fluence are really at the forefront of what is going on in the storage market. We see your projects all over the place, and it continues to be a pleasure to work with you. So thank you for the role you're playing in supporting the energy transition as we transition to a lower carbon, greener future. And I wish you all the best, and thanks for joining us.
Yeah, thank you very much. Thank you, Brian. Thank you, Matthew. I really enjoyed this session. And if there are some other questions, I'm sure you will follow up, and I can respond by email to the questions that we were not able to cover today. And enjoy the rest of this day on this wonderful event that the NVGL organized. Thank you very much. Good luck, everybody, with your projects.
Thank you, Medina. So for the next session, I'd like to invite Alistair and Mariana, who are waiting behind the scenes. If you could pop your cameras on and say hello. There's loads of questions on the chat, which is brilliant. So thank you ever so much for everyone who sent those through. There are some questions which Alistair and Mariana will be perfect to pick up, and there's a couple of questions which I'll come back to Brian on as well. So the idea of this session is just to explore some of the niche attributes, the technical attributes with some of the storage questions. And we've already seen some of the questions going that way from you all there listening as well. So thank you, Mariana and Alistair, for joining us today. Alistair, I'd just like to start with you. Would you mind just start by introducing yourself? And Medina talked about warranties in the previous session to set the scene. I'd just like to explore that a bit more. So after you've introduced yourself, it'd be great if you could share some thoughts on what's been changing, how warranties been changing to meet some of all these different market requirements that we've heard Medina talking about.
Yeah, sure. Thanks, Matthew. Hopefully you can hear me okay? You can hear me. Okay, good. Yes, so I'm Alistair Steele. I work as a principal consultant in the storage team in the NVGL. I've been in the storage industry now for about 13 years, so I've worked across a variety of projects, number of projects some years ago. I think the first one I got involved in was a very small flow battery project supporting grid DC supplies, which worked some of the time not so much. And then since then, we did a lot of research-based projects. So I worked on some high-temperature batteries, some small lithium units. We did some lead-acid units, looked at flywheels. We did some compressed air, liquefied air storage. So we looked a lot, and the basis of it was for deferral cases for the networks business, while still trying to make it market proposition. So looking at other revenue streams as well. More recently worked with DMVGL for the last 3 years, and there is much more focused on commercial projects, and these projects are, generally speaking, lithium-ion based solutions, but much larger in scale. We put in the first or the biggest battery in Europe at one point, which was a 1 megawatt battery, 7 megawatt hours. Now that would be seen as quite a small project. So definitely things are changing quite dramatically. Where 50 megawatts is pretty standard. We're starting to see upwards of 100 megawatt projects coming online in the UK. So yeah, very exciting time in the industry. In terms of the point you make on capacity, warranties related to capacity, efficiency, or defects warranties. It's a good point, Matthew, and I think it tells a bit of a story as well with where the industry's gone. So some of the very early days projects, and I'm talking maybe over 4 years or so ago, 4 or 5 years ago in the UK, when these projects were put in, the warranties had hard stops or red lines, where you could not go above a certain amount of throughput, or you could not do more than a certain amount of cycling in a short period. And if you went above that, your warranty was then voided. And I suspect there's a number of projects out there that actually have voided warranties already. But the market's changed quite a bit recently, and it's almost pretty standard now to have a flexible warranty. So these are warranties where you can go above your guaranteed limit, either throughput or cycles per day or cell temperature, whatever it may be. And this doesn't void your warranty, but it allows you some flexibility, but you suffer some increased degradation. And this makes it much easier for clients with their business cases, because the unknown part of battery projects is so key. What it's doing today may be different in 5 years and maybe different in 10 years' time. And then we're also seeing a bit more extension on the defect side. So we were seeing maybe 10 years previously, as an extra additional warranty. This is now becoming closer to standard. And then even we're seeing suppliers offering 15 years, even stretching that out further to 20 years to cover defects across the battery system, or even the power converters as well. So I think it's a changing story that the market has had to change and adapt to the needs of the customers, and then these flexible warranties are now getting pretty standard in the marketplace.
Thanks. That's great. Thanks, Alistair, for sharing those thoughts. And yeah, it's great to see the technology moving with the market as well. And the pace these markets are moving, I expect we'll see that going even faster over the coming years as well. Mariana, thank you for joining us. There's actually a couple of questions. I had a question lined up that I was going to start to ask you with, but actually there's a couple of questions in the chat box that are directly related to this. So I'm going to carry on asking you the question that I was going to ask, and the questions that are related in the chat, perfect for this. So it'd be great if you could start by just very briefly introducing yourselves to everyone. But I'd like to discuss the topic of safety. So we've seen a variety of energy storage systems around the world fail and catch on fire. There was news in the UK where we're based last year of a battery fire in Liverpool. Now, are there any energy storage standards out there which people should be following? What's going on with safety for batteries at the moment?
Thank you, Matthew. So I'm Mariana. I'm part of the energy storage team in Europe as well, just as Alistair. So we'll focus on the European part of this question. I have a background in physics, did a PhD on materials for fusion, and realized then that the key for the energy transition is in flexibility. So that's when I decided to move into the topic of energy storage, and I'm now already just over 5 years in the energy storage team at DNVGL. Over the past few years, we have seen changing this scene quite a lot. From really the first technical projects, demonstration and pilot projects, and now the commercial projects coming along, especially as Alistair was mentioning in the UK, with a huge focus in the UK. And this also means that the topic of safety becomes more and more relevant, with more of those systems coming up. And what you always see in these kind of situation is that the regulation and the standards is always lagging behind, because during tests, during projects, you'll find out more and you learn lessons that you need to implement in the next situations. This means that the last year 2 important IEC standards have been published. So when you look at the international market, there's kind of the UL standard that has been followed, that is followed in the US mainly, which is the UL 9540, which focus on safety for energy storage systems and equipment. And you have then the NFPA, which is then the 855, which is developed by the National Fire Protection Association. In Europe, we use our own standards, and we mainly focus on the International Electrical Committee standards. So you have then the 62933, which focus on the safety of grid-connected systems, and another one, the 62485, which focuses actually on the requirements for installation and operational use of it. So those 2 are the main guideline here in Europe, and the best practice to follow currently. This is not actively implemented and used yet. So we also see that if you look at the regulation, there's not a direct mention to these standards yet. And the standards are also not fully complete, or how do you say this, developed, since it describes mainly a risk assessment that you need to do and the important hazards you need to take into account and a way to assess safety, but it's not a checklist yet on how much distance you would need to have between cells or modules to prevent any fire propagation. Yeah, there's a lot more to tell about it. Shall I go on, or shall we move to the next?
Maybe that's fine for the moment, and then we'll come back to you, because there's some other questions that are related about safety as well, and I've just seen another one come in. But maybe what I'll do actually is I'll skip back to the warranties, let some questions come in on safety, and then we'll come back. Now, I'd like Brian and Alistair actually to have a go at answering this question. And Brian, perhaps more from the market, the impact on the business cases, and Alistair, the sort of technical impact of this. So the question is, in order to meet the capacity requirement of the battery energy storage system over the lifetime of the project due to battery degradation, do you see augmentation either yearly or sort of increments throughout, or oversizing the system at the beginning being a more popular solution at the moment? And technically, I guess, is there something that people should be aware of, whether they're going to do one or the other?
It's a great question. It comes up a lot, and it has a little bit to do with your risk tolerance, and then quite a bit to do with economics. In the U.S., we generally have seen we've seen both for sure. I think what we're seeing that's more common tends to be augmentation strategies, and mainly this is due to the perspective that an owner is willing to take on the decreasing expected future costs of batteries for replacement. And if you design your system up front expecting to augment at a periodic basis, then you can make sure that you leave the physical infrastructure, the concrete pads, the extra container space, to make that augmentation a lot more cost effective when it actually comes about every 3 years, 5 years, 10 years. We've seen a wide range. But there's essentially a trade-off you can think about in terms of whether you want to spend more capex up front. In the US, sometimes we've seen oversized systems because of the investment tax credit that I spoke about earlier. That gives you a rebate, a credit on your capex, your upfront costs. So you could conceivably oversize your system today and you get 26% of that cost back, and let it kind of degrade at a relatively well-known pace over the life of the project. And that might be beneficial from your perspective. The other approach we've seen is actually more of I call it like a just-in-time approach, where instead of having a planned augmentation strategy, there's more frequent testing, capacity testing of the battery system. So every 6 months, a lot of times capacity testing is about every year. Some folks have taken that to more extreme and do it maybe every 6 months or every quarter. And then when they see the actual physical usable capacity of the battery hit a point at which they know in the next quarter or next 6 months it's going to be below what they need to make their revenue, then they go out and make the procurement through maybe an MSA with a vendor. And I find that very interesting and unique to storage, because as long as you have a supply contract and you know you can get the product on time, or you have a couple vendors to provide the product, the actual physical installation of that product onto a well-designed project can be pretty quick. From a physical infrastructure side, there's not that much site work that would necessarily need to be done. So that's also an approach taken by some project owners that have a little more risk tolerance. The one other piece I'll add, going back to the flexibility warranty, totally agree with what Medina and Alistair had said on that. And shameless plug here, one of the reasons that is starting to come into play is because projects are operating in a much more complex way. And one of the ways that we've tried to help customers manage that is by creating something, essentially a warranty tracking mechanism that uses actual operational data from customer project sites and tracks that against these increasingly complex warranties, so that customers have a close to real-time view inside the battery. Because, as mentioned, the capacity test, where you actually physically know exactly how much usable capacity a project has, is not always is not done very frequently. And so we've created a product, a software platform that can actually help customers along that side.
Thanks for sharing that, Brian. Alistair, is there anything you wanted to add on the technical side? I mean, is one of these easier technically than the other, to oversize it or augment it?
Yeah, I think it's a really good question, and it's something that we do quite a lot of work on, and we get quite a lot from our clients. I guess the big difficulty is the battery manufacturer doesn't know the exact usage profile of the battery. So you may have an exact usage profile that you're doing in day one, but that could change in year 5, in year 6, in year 10. So that is one of the big challenges. So we do see some manufacturers calling out different ways, like they may be augment in a particular year, but really they don't really know exactly when. They want some flexibility around that, whether it might be year 9, year 10, year 11. Really depends on the usage and depends how much the whole system degrades. And then once they know exactly what's happened, they can either call that out, and that can be done. We see it sometimes done through additional OPEX. So you can pay for a guaranteed amount, and you pay that extra, and then they will come and install it. Or you can see that they can do actually call out augmentation points if you want. Right, we'd like some additional capacity here, so please upgrade this, and they can pay for that. But technically, it's not a significant challenge. The point that Brian made is good, that as long as you're planning for this up front. So if you're building it, it's not too much extra to put in some extra concrete plinths, that type of thing, or you can design a bit more flexibility into your system so that you can have, your system can accept different types of cells. And then the last point, I think, is one of the difficulties is just the fact that you're having to predict something out in 10, 12, 13 years time. The technology is moving very fast, so it's hard to estimate what the price is. It's hard to even work out whether they'll still be using lithium-ion batteries in 13 years' time, whether something else comes along. So that part makes it really tricky for the suppliers to give these guarantees. So we have to build some risk into that. So if you're getting that guarantee through some OPEX, you're potentially paying more than if you're willing to take the risk, project some prices coming down, and pay for it for that just-in-time model.
Thanks for that, Alistair and Brian. So I'm going to jump. We started with a bit of safety, and then we jumped to warranty. So I'm going to jump back to safety and ask Rihanna. There's a question that's come through actually. It'd be really interesting if you could say something on what safety improvements we've had that we're seeing from the technology. I mean, is there anything that's happening that we see in how this technology is being rolled out that's making the systems safer?
Yeah, the most important thing we actually see is that the awareness of it raises, which means that the system designers are now actively integrating the aspect of safety in the system and take the relevant measures. What I actually forgot to mention in my introduction is that I'm responsible for setting up a collaboration with the fire brigade to be able to build a test center where we can actually also test the fire propagation behavior to get more knowledge and more information and more, let's say, real life experience with how such a fire behaves, how it propagates, and what the most effective measures are to prohibit propagation. So what we currently have seen is, for example, as a result of the Arizona incident in the US last year, that it's now much more common to also implement a deflagration window in a container. So to avoid or to take into account that there's a risk for gas to build up above a flammable or an explosion limit, and to make sure that it's directed in a way that you can handle such an explosion. This means that there's more attention also for modeling in that perspective, and also thoughts about what amount of ventilation or what kind of ventilation would be needed. We also see a trend towards smaller systems. So instead of the big containerized system, you now might see at least a separate room for the electrical part and the battery room itself, so that if any sparks would occur, that cannot, let's say, spark any incident with the batteries itself. But also we see a trend towards some smaller systems like the Fluence cubes or the Tesla systems. We see them more common, for example. Yeah.
Thanks, Rihanna. I just want to pick up actually on one of the things you were talking about there with the test center, and how important is it that people test batteries? I mean, like, is it if I was going to go and deploy a battery, what value could I get from testing these assets?
Yeah, so it will help you to understand the impact of the fire propagation. So what you always need to take into account, although the risk is very small. So with energy storage system, there's inherent a lot of energy stored at one place together. And there's always a risk that energy can be released at a single time. This is a very low risk because probability is very low. You can think about quality of your system, quality management, buying proper cells. But you also have to take into account that you might have 10,000 of these cells in your container. So you need to take into account that there is a incident with one of your cells. And from there on, you need to make sure that that incident cannot propagate into a large event. You can do that by having distance between the cells, by having thermal barriers, by using a fire suppression system. And in order to decide on your specific system for your application, and it can be either a system close to a building environment or in the middle of nowhere together with renewables, then the impact and the risk assessment that you make might lead to different decisions. So the only way to really understand what happens when such a cell or such a model catches fire, and whether you manage with your design to prevent propagation to the next one, the only way to know it for sure is to test that.
Yeah, thanks, Mariana. So yeah, there are things coming in, and there are new safety measures coming in that are important to consider, and it will allow us to actually understand how safe these systems are and what will happen if they're put under those situations. And it's important, I think, as you say, that people are build awareness for safety and not just take it for granted with storage systems, because like you rightly said, they store huge amounts of energy, and we need to make sure that that's safe in the systems as well. Alistair, so how, I mean, you work on lots of projects in the UK. I mean, how are people actually, are these systems complying to these standards? Like, I mean, we can put standards out there, right? But the industry's actually got to be complying to them. There was a request actually for you to talk slightly louder when you when you answer. So yeah, just keen to hear your thoughts around that.
Anyways, my accent. Yeah, sure. Hopefully you can hear me if I come a bit closer and the microphone picks it up. Yeah, so it's how projects are complying with these standards. That's the question. Yeah, so it's a difficult one. It's not always clear exactly which standards apply to which specific projects. So something we do spend a good bit of time with clients on. And typically the way that we would do it is we would go through, we have a list of standards quite long, but the standards that we think would apply to the electrical side, transformers, and then the best thing to do is that we work with the client, and then the client will share this list and work with the supplier to go through which standards they believe to apply. And maybe some that don't apply to their particular technology for whatever reason.
Yeah, sorry, Alistair, your microphone's completely gone, so we can't hear you, unfortunately.
Okay, maybe go to. Do you want to go to Rihanna, and I'll try my.
Yeah, I think just to pick up the bits of it I did get was that the roles that we play is the roles that need to be understood is what standards actually that the system needs to comply to in the first place. So it's actually developing that list of these are the actual standards that are important, and then looking at the actual technology itself and how it meets each of those standards. But actually there's a hard bit in the first place of even understanding what those standards are.
Maybe what's good to add here, Matthew, and to realize for the audience is that in the European Union, we see now the initiative to change the current battery directive into battery regulation. And although this is mainly focused on it's mainly coming from the Green Deal and the Circular Economy initiatives, so it mainly puts into account the reuse, recycling, performance aspect, but it also has an initiative where the CENELEC, so that's the European Standardization Committee, is asked to come up with a standard on performance as well as on safety. So what we expect there to happen is that the next 3 years will be spent to harmonize the standards which are mentioned from the IEC, for example, and put into also mandatory regulation on a European level instead of the different countries making their own rules and regulation.
Yeah, thanks for adding that, Rihanna. That's a really important point and something that's really important that we track as projects are installed. Right, I'm just going to throw a complete curveball in at the end. At the beginning of the talk, I promised that we'd hear from Brian on the impact of batteries on greenhouse gas emissions. And so I'd like to end on something completely different and give Brian the opportunity to share some thoughts with the audience, because this is something that I haven't ever considered much of, and I know many people out there won't have considered much of. So I'm going to give the final question to Brian before we wrap up and say, Brian, we've discussed this previously, and I was very interested in the impact of energy storage on greenhouse gas emissions. And as we transition to net zero, it'd be great to hear your thoughts on how operating a project can actually impact greenhouse gas emissions.
Awesome. Yeah, very excited. This is a topic. I think it's a question that not enough people are asking. We spoke a lot with Medina about how storage can be utilized to integrate renewables into the grid through various ways, but we can't forget that energy storage is a net load on the system. There's always less energy that comes out than goes in. So if you charge it with renewable energy, you're going to get a little bit less that actually gets utilized for whatever that service is. Now, there's a lot of benefits, right? Storage could help bring that renewable energy to the grid in a more cost-effective way, but there's still a little bit less that comes out than goes in. And we should be honest in the industry about how that may impact how you think about the greenhouse gas benefit of a given project. And what it mostly boils down to, and I focus mainly on the operational side of storage, how it's charged and discharged on a daily basis. There's certainly some embedded environmental impact of the production side, but let's sit that to the side for now. Essentially, the way to think about it, the way we think about it, and other folks who are looking at this think about it, is that there's an emission or an avoided emission impact associated with the energy that you use to put into the grid, into the energy storage project. It could be renewable energy, so it could be zero emission energy, but that renewable energy could have also gone directly to the grid had it not been for the storage system. So as long as it's a grid connected project, charging the battery, even with renewable energy, still has an emission impact due to the avoided emissions that would have happened had that renewable energy gone directly into the grid. So it's important to understand what that storage charging energy and what emissions are being offset from the grid at large, the grid it's connected to, are being offset. And then when the battery discharges and puts that energy back onto the system, what power plants are not being used or are being used less, and what are those avoided emissions that are happening when the battery discharges. And much like the way energy storage systems at its simplest make money based on the volatility, the difference between the high and the low energy prices, the way storage impacts greenhouse gas emissions of a project is by looking at the difference between the emissions during charging and during discharging, net, and then subtracting out any efficiency losses. And it's important to realize, and it's not a bad thing, if energy storage projects may have some slight net increase in emissions relative to some other baseline, relative to just maybe a solar project on its own. Because the storage is providing other grid value, and it's also bringing that renewable energy to the system. So there are benefits, even if this calculation shows a net slight increase, but it doesn't have to be an increase. In grids that have a lot of renewable energy, grids like California in the US, for example, some of the incentive mechanisms, particularly one called the Self-Generation Incentive Program, actually require, as a means of compliance for this incentive, to demonstrate through this accounting mechanism that the storage project reduces the net emissions at the site, even if it's charged with renewables. And this approach is, I think, a very important and reality-based mechanism to ensure that the storage system is doing what at least this particular incentive is requiring. And this incentive is designed to reduce greenhouse gas emissions. Certainly, if you have a goal of just making money with a project, then this accounting mechanism may not be important. But if your investment in a storage project just assumes that because it's storage, because it's renewable energy paired or co-located, that it necessarily meets all the criteria that you have for a green investment, I think it's important to think about that in a much more quantitative way. And we're lucky now that we actually have incredible treasure troves of data that can quantify the grid and localize grid emission impacts of energy storage, charging, and discharging. There's companies like WattTime that actually provide hourly or more granular minute-by-minute emission curves that can be used to say, when you're charging a battery at any given instant, what is the emissions of the grid that you're either avoiding or that you're increasing due to charging or discharging. And by using those data sets, it's fairly straightforward to quantify, and it is a service that we offer to a lot of our clients and hope to continue to support, because DNV as a whole has very strong and stringent greenhouse gas emission mitigation goals as a company, and also for the work that we do. And so we'd like to make sure that the industry moves along in lockstep with that approach. So certainly love to chat about it and can always speak more.
There we go. Not something that many of us are considering with our projects. So yeah, if you are looking at further projects, Brian would be more than happy discuss with you the impact of greenhouse gas emissions of your projects. So that's it for our session today. Alistair, thank you very much for sharing your experience with projects. Mariana, your expertise in safety it's great to see that this really is at the forefront of your agenda and our agenda as DMV. And Brian, you've done the double stint, so thank you for staying with us through both of the sessions today and playing your role throughout the session. And lastly, thank you to the audience. There's been loads of questions. We appreciate everyone who sent those through. We're here to support your storage questions and discussions as you go, so please do reach out to me or any of our experts if you've got any further questions. So thank you very much for joining us, and we'll speak to you all soon. Bye.